Okay, so today I'm going to talk about the answers to the test. Well done to those who did it, and especially well done to those who did well. About 2/3 of the class did the test, but a third didn't. I'm quite disappointed in those who didn't do it. I know it's difficult to learn from home, but I need you to be trying your best, everything I give you, you need to do. But I am going to go through the answers, and then we're going to do a sheet today that you have to decide which distribution is which. So this one says a planet in the Milky Way is struck by an asteroid of 6.9 times per year. Now I just want to, it says here Poisson, so you know it's Poisson, but in your real exam it's not going to tell you which one's which. So the key thing for Poisson is that it's an average over time. It's a discrete distribution that has an average over time. That's how you know you have to use the Poisson distribution. So here it says the probability that a planet is struck by an asteroid at most 4 times. So at most means it includes 4. So I'm looking for the probability that x is less than or equal to 4. Here it tells me my average is 6.9 times per year, so my lambda is 6.9. So into my graphics calculator, I've actually already done this, but I'll do it again. I go distribution, Poisson, and it's PCD because it's less than or equal to. And my x value is the one that's in here, is my 4. My mean is my lambda, which is 6.9. Press equals, and it gives me my answer. And that's question 1. Okay, question 2. It says the manager of a football team is responsible for bringing the snacks to the game, but there is a probability of 0.1 she forgets. The team plays 12 games in a season. What is the probability the manager forgets snacks more than once in the season? So this one we know there's 12 games in a season. We're counting numbers, so we're a discrete variable. It says the manager of a football team is responsible, but there's a 0.1 probability she forgets. So that's our probability of kind of failure in this case. So we have a probability of success and failure. There are two distinct outcomes. They're complementary. So it can happen or it can't happen. Even if there's more than two events, the event can happen or it can't happen. So probability she forgets is 0.1. Probability she doesn't forget is 0.9. So that's how I know it's binomial. I have to find the probability that she forgets more than once in the season. So that's greater than 1. So that means I want 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. That's how many times she forgets. To work that out, I need to work out less than or equal to something. So I can't work out this without working out x is less than or equal to 1. I'm going to work out this part and take it off of 1, which will give me this part. So I'm working out the probability that x is less than or equal to 1, this part here, and taking it off of 1. I'm going to write my parameters down. So my parameters are this information I know. I know my number of trials is 12 because there are 12 games in a season. And my probability is 0.1 because it told me in the question. And so I'm going to go into my graphics calculator. My x is 1 because I'm doing less than or equal to 1. It's the number that's in this part. My number of trials is 12. My probability is 0.1. I'm in binomial CD, binomial distribution now, and I get 0.659. To work out then greater than 1, I have to take that off of 1. So 1 minus 0.659 is 0.341. This question is slightly harder. It requires you to do a couple more skills than the first one of the A Thai restaurant sells meals to take away or dine in. 4 out of 5 meals are takeaway. So one lunchtime restaurant sells 20 meals. So first thing we can think about is what is the probability they are takeaway, and change it from a number, I'll take another number, a fraction, to a decimal. So 4 out of 5 becomes 0.8. So my probability is 0.8. It says find the probability between 15 and 18 inclusive, so it means includes 15 and 18 of the meals are takeaway. We know this is binomial because we have a probability of success and failure, or two outcomes. So we have takeaway or not takeaway. So that's our probability. We have a fixed number of trials, 20 meals. Those are the two main things. We have an N of 20, and we have a fixed probability. The difference between Poisson is it has an average probability. So we're looking for binomial, mean, average, we're looking for Poisson. Okay, so to work out the probability that's between 15 and 18, one way you can do it is you can go into BPD and work out 15. Write that down. So that's the probability that x is equal to 15 because you're in BPD. Write that down, then do 16. Write that down. 17, write that down. 18, write that down. You can do them individually with PD for one precise value, and then add those four values together and get your answer. That might be an easier way. The more smooth way of doing it is to work out, you can work out the probability that x is less than or equal to 18. So all of this, and take off the probability that x is less than or equal to 14. Because that'll just leave you with the range of values you want. We want between 15 and 18. So if I work out all of it, all the way to 0, and take off the part I don't want, then I'll be left with the part I do want. I know my P is 0.8, I know my N is 20. I'm going to go into my graphics calculator, distribution, binomial. Since I'm doing less than or equal to, I'm going to CD. I'm going to use 18. Write that down. Then I'm going to use 14. You don't need to think about this because I've already written it down earlier in my question. 14, 0.196. And like I said up here, I'm going to take one away from the other. So 0.931 minus 0.916 equals 0.735. Now, for some reason, Education Perfect cannot understand if I was to write it like this, and in the some of the way some of you wrote it, I didn't really understand. You got the answer right, and I had to go back and remark just because of formatting. So at any point in Education Perfect, just come down and rewrite your answer all on its own with nothing else, and Education Perfect will figure it out if you do that. Okay, next question. On average, there are 1.5 typos per page. So I have an average over a constant period. So I know it's Poisson straight away. My lambda is 1.5. It says, what is the probability that on a randomly chosen page there are at least 4 typos? So at least means greater than or equal to. I didn't write out my numbers for this one. So 0, 1, 2, 3, 4, 5, 6, 7, 8, dot, 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 dot. So it's saying there are at least 4, including 4. Now remember, for my calculator, it needs to be less than or equal to. So I want to get rid of 0, 1, 2, and 3. So I'm going to take this off of 1, so 1 minus 3, and x is less than or equal to 3 is going to be what I need to do. So in my calculator, I need to be in Poisson CV. So I've got distribution, Poisson PCD. My lambda is 1.5, that's my mean. My x, because I'm doing less than or equal to 3, is 3. And then I press equals, and I get 0.934. Now, that is less than or equal to 3. Remember, I need to take it off 1, so 1 minus 0.934 gives me 0.066. Okay, this one I'm just going to go straight into into the calculator. So it says the length of a full-term newborn baby is approximately normally distributed with a mean of 50.3 and a standard deviation of 3.3. So I put my mean here so you can see it. And it says what portion of full-term newborn babies are more than 50 centimeters long. So I'm going to go into NCD, always NCD for raw normal. My lower, I'm looking at if they're more than 50. My upper is a really big number. My standard deviation is 3.3. And my mean is 50.3. Enter 0.536. That's all we expect. It's just over half based on our diagram. This one, height New Zealand woman. We have a mean of 163, standard deviation of 7. Even giving me the diagram, really easy. My lower, I'm looking for the probabilities between 160 and 169. So my lower is 160. My upper is 169. My standard deviation is 7. And my mean is 163. Remember, when you're doing these in your exam, you need to make sure you're writing out what you write in the calculator. Say lower, upper, standard deviation, mean. Write that down. And the answer is 0.47.